what we're going to do next, we just did, Mariah, we just did parabolas. Okay, Jake, Joe, face the front, please. I know, I want him focused here. Not with you, Julian. Not with you, I want focus up front. Okay. No, this isn't that bad. Now, we're going to be studying quadratic equations. We've done some graphing with them. So you get parabolas. Now we're going to use quadratic formula to find out where those x-intercepts are. But to do that, I need to be able to simplify a radical, a square root. So like this. Square root of 16. You may use a calculator to help you, but I want an exact answer. And what is a square root? Cole? Joe, do you need to move up front? Okay, then you need to be writing stuff down, and Ray, you need to face the front. Okay, what is the square root of 16? What is it? Joe? What's the square root of 16? It's 4. In other words, what number times itself gives you 16? 4. Okay, this should be easy today. Now, you guys, we need to know what prime numbers are, Henry. Do you know what prime numbers are? No, no, no. That's not what I'm asking. What are prime numbers?
Prime numbers are numbers that are odd, mostly.
They are 100% numbers. You are right.
Numbers that can't be simplified.
Okay, numbers that can't be factored. Actually, numbers that have only 2 factors. Good choice. I don't even know if you know what factors are. You should, but that doesn't mean you do. So like 2. What are the 2 factors of 2? 1 and 2. Well, we're going to get them set out. Okay. Put that away, please. Okay. Okay. Shh. No, they're not. Well, they will all be odd. Yes, except for 2. 2 is not odd. But are all odd numbers prime numbers? No. Okay, Joe, what's the next prime number? We could make a list of numbers. Let's try 3. 3 is 1 times 3. Now, why is 4 not a prime number? Because 4 gives you 1 times 4 or 2 times 2. So that has more than 2 factors. So 4 is not prime. In fact, does anybody know what it's called if it's not prime? Starts with a C. Somebody was thinking on it. Oh, was that Jeremy? Composite. Good guess. The composite number. I think I spelled that right. Now, what about 1? Is 1 prime?
Yeah.
What do you multiply by to get 1? 1 times what?
4.
That's it. It has to have 2 factors. So guess what? 1 is not prime, and 1 is not composite. It's a very special number. So it doesn't have the properties of the prime. So we're going to cross that one out too. What's the next prime number? 5. I'll go back to my black. 5, because it's 5 times 1. And you really, I don't think you need to know much more than that. But what about 6? What about all the even numbers? No, they aren't going to work. So what's the next one after 5? 7. And then you're going to say, well, then 8's obviously not prime, Joe. But what about 9? It's an odd number. 9 has 1 times 9, but also what? 3 times 3. So guess what? Not a prime. Okay? And that's probably all you need to know to do this assignment. A number is considered prime if it has no integer factors but whatself and 1. It has exactly 2 factors. I think you have that on your handout. Yes or no? I am a sailor, so I have a sailboat, and when you race a sailboat, it has a number on it. I picked a prime number. It's also, the name of my sailboat is Look Homeward Angel, which was written by Thomas Wolfe in 1929. So this number on my sailboat is 29, a nice prime number. Because numbers are kind of fascinating, actually. There are lots of books you can read about numbers. There's actually a lot of fiction books with numbers in it. I think it's 23.
Tragic story about how 789.
About what?
How 789.
Yeah, 7, 8. Oh, poor 9, 7, 8, 9.
The 7, 8, and 9.
Yeah.
Like, it ate it. Like,
I really
past
don't
tense
think
of
a big
eat.
deal about that.
Okay. Well, these are your prime numbers. And it's nice to have the list. You can use your notes. So you have a list. Okay. And Mariah, I need to put your iPad away, please. No. Close it. I know. No, I have notes right here for you. So let's see how we're going to do this. We want to simplify a square root. Now, these are the steps, and I've never done it this way, so I went and looked at the teacher's notes, and I go, oh, that's an interesting way to do it. I kind of liked it. There are two ways to do this. Okay, Joe, Julian, you're not going to know how to do this because I don't think those numbers are those steps are very clear, not for the first time through. After that, it's great. It says find a prime number that will divide into 18. Now, I want to simplify it. You can't have a radical that has a perfect square underneath it. So this list of primes, all the numbers that can be under your square root and be simplified will be these prime numbers. If you have a composite number like the square root of 8, there is a perfect square that goes in there. What are the perfect squares now that I'm thinking about it? And why are they called squares? Because they make a perfect square. If you take a square, side 1 by 1, what's the area? Remember area? Length times height? Width? Area is equal to 1. That's right. That's a perfect square. What about another square? It's 2 by 2. What's the area? So that's why those are called square numbers. If you didn't know that before, what's this another square? Base times height, remember that? 3 times 3. Area is equal to 9. Those are the perfect squares. And back in my day, when I was in 6th grade, we didn't have calculators, Joe and Julian, so we had to do things by hand, and I had to memorize all the perfect squares.
A lot of words.
No, I still know 'em.
That's like,
What's a square with sides 4 and 4? What's that area? Area is equal to 16. So if I know the perfect squares, then it's not bad.
is that why they call it square root? 'Cause it's
That's right. All of that's continued. Yeah, all of that makes sense. So you've got 1, 4, 9, 16. And if you notice anything interesting about these, maybe you didn't. If I subtract this, how much is that?
3.
That's 3. If I subtract that, it's what? No, it's 5. If I subtract this, it's 7. So if I were to subtract those two numbers, it would end up being 9. So what's the next perfect square? No, what's 9 and 16? 9 plus 16 is 25. The next one would be 11, which gives me what? 36. Those are your perfect squares. And pretty much you don't have to go much higher than that. What's the next perfect square? So we have one more. 7 squared is 49, or you could add 13. Okay. The rule for radicals is you cannot have a number that's a perfect square that divides into that. Not right now. Okay, once I teach this, it'll be fine, and it won't be that long. So I want to see if there's a perfect square that goes into 18. So what we're going to do, Cole, if you put that away, please. What? No, I'm going to teach you a way to do it. I want to find a prime number that divides into the number. We're going to do this really weird. What's the first prime number? Just trust me. 2. Yeah, there's a perfect square that divides into 18. Does anybody know what that perfect square is? 9. Now, that's the way I'm used to doing it. I look for the perfect squares to divide in. Well, 18 is what? 18 is 9 times. 9 is. 9 times 2. And there's properties of these radicals, which we kind of skip these things, but I can rewrite this as the square root of 9 times the square root of 2. This is the way I used to teach it. But I'm going to show you a nicer way, I think. I want the biggest square number that will divide into 18. That would be 9. What is the square root of 9? 3. Okay, that's one way to write it. Now, why do I not care really too much about simplifying radicals? Okay, David? We have calculators now. I'd really rather have a decimal. I know. So it's kind of silly to be doing this. However, I believe it may be on your MCAs when they come up.
That's next week.
I don't think they're on MCAs, but they are on the ACTs. Yeah, MCAs are next week. That would be Tuesday and Wednesday. Ninth graders are doing writing. 10th graders reading. Next week we have a crazy schedule next week. Tuesday and Wednesday. I will see you guys not Tuesday, but I will see you Wednesday. You're going to go to periods 1, 2, and 3 on Tuesday, 4, 5, 6 on Wednesday. Because you have MCA testing. No, you do your testing, and then I don't know where lunch fits. Oh, lunch is weird. Depends on what subjects you're in. But we'll worry about it next week. Yes. I'm not surprised.
Can we learn this?
I know, I'm trying to get there. Joe, come on up front, please. Come on. You can ask me a question and come up front.
Can we please?
Yes, we are. I'm going to answer a question. Okay, guys. Shh. Joe, up here and ask me a question. Please. Okay, I'm going to show you another way to do this. Joe's not ready to ask me a question. Okay, David, we're going to do the square root of 18. So we're going to take 18, and we're going to divide it by a number. Well, what number goes into 18? What's, by the way, have a seat, please. I got 2, 3, 5, 7, 9. I'm going to start with a 2. Okay? We'll divide by 2. So I divide by 2, I'm going to be left with what? 9. What goes into 9? 2 doesn't go into 9 any longer. Let's try 3. And 3 goes into 9 how many times? 3. And you still keep dividing. You want this to be 1. So what goes into 3? 3 goes in what? Once. And that gives you what we call prime factorization. It says repeat until you get to 1. Okay, when I simplify the square root of 18, I want to find matches. You guys played the game concentration, right? With the cards. Oh, we should do that someday. You put cards down and you turn one card up, and then you try and turn another card up, you try to match, and you have to remember where it was. Well, it's the same thing. We want matches. Where are the matches? The 3's match. So that's what's going to go on the outside of your radical. You take one of them because it's the square root, and then this 2 goes inside. And that's how you can simplify it. The other way to do it is to figure out the biggest perfect square that divides into that number. I like both ways, but this way I think is pretty easy. We have to find all the matches. Let's try another one. So you have it in your handout. 18. On your handout, yeah. We always take notes. What else? What else is new around here? No. That's right, David. Okay, so I'll give you a chance, and you need to turn this in. You can do it either way. I mean, I have always taught it this way. Then today I looked this up. Well, let's try another one with the new. Well, let's do both ways. But now I gotta wait a second. This way? Okay. Okay, Cole. While we're waiting here, what's the next prime number? 10? 11? Yep. 12? No. Jake, what's the next prime number?
9 is even on this sheet.
I don't care. Oh. You're right. I forgot 9. Okay, what's the next one? After 11. Does 12 work? Now, what's interesting about prime numbers is people have looked for patterns here. There is no pattern. Well, I don't know if they're random. If you could find a pattern so you can make a prediction and you can find the 100th one, we could retire forever. Yes, really. Okay, we ready to go on to try the next one yet? Okay, now you need the answer to this, and the answer to this, Lalo, is this. Take one of those that matches outside, and then that one goes inside. Because that's 9. Okay, can I change pages yet? We should easily get this all done today. Okay, so I've got like 5 examples. 27. 27. You have the wrong page. There it is. You got the numbers are right there on the bottom. Okay. So should we try this this way first? Okay. What's the smallest prime number, Henry? Joe?
3.
And put that away.
No.
And Joe, you're supposed to sit up front. Does 2 go into 27?
No.
3. 3 into 27 goes how many times? How many times does 3 go into 27, Joe?
9.
Joe, Enough. 3 into 27 goes how many times? 9. I'll take it all then. So you're disrupting me and everybody. Okay, you're going to put that away? Yeah, I'll give it back. I don't want it. Okay, now what goes into 9? Smallest prime number you can think of, Joe. 3. I kind of like to do this, I think. How many times does 3 go into 9? 3. And then what are you going to do? Divide by what again? 3. And so you finally end up with what? 1. That's when you stop. And you only take the matches. Okay, Mariah, what matches here? It has to be even numbers.
3, 3. Can I have number?
This is 3. That goes outside, but what's still not matching?
3.
So it's 3 square root of 3. It's kind of a foolproof way to do it, I think. But can you think of a perfect square, Jake, that goes into 27? No. Perfect squares are 1, 4, 9. What's the next one? Joe, face the front, please. Take your headset off. What's the next one? 4 squared. Shh. Ray, what's the next perfect square? 1 squared, 2 squared, 3 squared, 4 squared is?
5 squared.
What's 4 squared?
7.
4 times 4.
4.
16. What's 5 squared?
25.
25. Next one.
36.
36. Which is the biggest one of these that divides into 27 evenly?
25.
Okay, Suzanne, put that away. 9. So this is the square root of 9 times the square root of 3, because 9 times 3 is 27. So what is the square root of 9?
3.
Which way do you like?
That one.
The first way?
Yeah.
It's kind of nice and easy to do. Okay, Joe? Joe, did you get this one down? Are you ready for me to turn the page?
No, wait. Hold on.
If you're ready, you turn the page and try the next one. They're not terribly big numbers.
What's the next one? Let's see.
Well, that was page 4, so you go to page 5.
I have the one back. Or I'll have 2 pages.
Oh, you're missing the third?
Yeah.
How did I miss you? There you go. Yes.
Thank you.
Oh, you're okay.
Wait, what can we do?
Oh, this one's easy.
Oh, do you have any pictures from your trip?
I do, but not ready.
Yeah, just show us.
This is what?
Please.
Square root of 36 is 6.
That's it.
That's it. I mean, you want to do the process? It's 6, and it goes in 6, and you divide by 6. There's your match. I just know what that one is, so it seems kind of silly to do that. So if you know it, it's great. Thank you. Okay, you ready for number 3? And it shouldn't take you that long. Oh, 60. Well, finding the biggest perfect square that goes into that might be tricky.
2.
So let's divide. Do you want to divide by 2 or 3? It doesn't really matter.
2.
2. You want to divide by a prime number. 30 is not prime. Okay, Henry, how many times does 2 go into 60? 30. Now what are you going to divide by?
2.
Prime number, 2. You can do 2, 3, 5, etc.
15.
Okay, 2 is 15. Now 2 is not going to work.
5.
5.
3.
3. Okay, and let's see, 5 goes into 3. 3 goes in once. Okay, so matches. What matches? That goes on the outside. That's what comes out, so that's 2. And what goes on the inside? You multiply those together. 15. Would you have realized 60 is 4 times 15?
Oh my gosh.
Almost. They go fast. Because this is the square root of 4 times the square root of 15. How come nobody's asking me where the square root sign goes? What happened to it?
So the answer goes to the left. They went boom.
This is the answer. Both of these are going to be an answer. What's the square root of 4? When I say that's 2, it's used up. It's gone.
Wait, how do you get 2 then?
What's the square root of 4?
2. No, how do you get 2 on the left? Oh.
Because the 2's match. Every one that matches, I pull out. But I only pull 1. Because that's what a square root is. Okay, 28.
14.
Oh, I'm sorry.
Right?
Start with the process. What do you start with? Divide by what? 2. Henry, leave him alone, please. Jake, do you know what to do with the next one? Are you ready? 28. We ready? Suzanne, put that away. 28. That's not prime. Start with a prime number. 2. How many times is 28 divisible by 2? It's 14, right? Now what are you going to divide by? 2. And what do you get? 7. What goes into 7? 7. 1. I divide 7. This is what I have. 7 here. Divide by 7, I get 1. So I got a match here. So it's 2 times the square root of 7. I what? I do. Right there. If I had had a 2, 3, and 7, then I couldn't do it. Times. So let's do it the other way. What perfect square goes into 28? 4 times 7. What's the square root of 4? 2. Some of you will prefer this method and some of you will prefer the other. I don't really care because they're both right. Okay, ready? Not yet. Still the same no matter what you do. Hello. Okay, ready? 128. I don't know if I'm going to think of the biggest perfect square. You want to come up and do it? Okay, we have 2 problems left. This is it. That's it. And then I'm going to give you a worksheet again. Oh, is this the last one? Oh, perfect. You should finish with time to spare. Well, maybe not. I think you should finish. Look at that. Nice job. Okay, I'm collecting this one today, and it's 0 if you don't turn it in today. Got it? Because there's no reason to not turn it in. And you get points for that. So you should copy this one down and do this with us.
No, thank you.
Not an option. Yes? Did you get it? Now we have to finish this. Oh, good. It's not done. Not done. Joe, how do you finish that? It's not done. No, I have to staple, staple, staple. Okay, you guys? Well, let's take all the matches. No, you match 2 at a time. Okay, Suzanne.
Miss Golombesky? Thank you, but I think I already finished this stuff like 5 years ago.
You can do an answer key. Oh, you're working. Never mind. Okay, you guys. Okay, guys. Quiet down. Cole? Can't hear you. Alex? Alex. What? Not till we finish this. Not till we finish. Well, we should be done. Mariah, how do I finish this? Jake, how do I finish this? Yeah, how many matches are there? There's 1, 2.
And then 2, so 4.
2. 2. And left with the square root of 2. So now it's not 6. Multiply. 8. Okay, you think you guys can do this on your own now? You have the rest of the time. Now, you need to have this one complete. And we'll find a stapler and we'll turn it in. I want to staple it though.